So thank you very much for the introduction. Thank you for having me. So before getting started, I just want to tell you that the slides are already available online. You can get them either by scanning the QR code or going to this link. And the reason why I like to share the slides early is because I'm going to be providing a bunch of code examples, some links to deep dive on some topics. And I think it's just easier if you have the slides now rather than looking for them later. And while you get that and you are distracted, I'm going to be telling you a little bit about myself. So my name is Luciano. As you might guess, I am Italian. I am an AWS serverless hero, and I'm a Microsoft MVP. And I work as a senior architect for a company called Fortiorem, and I'm going to be telling you a little bit about that in a second. And as Jane said, I'm the co-author of this book, Node.js Design Patterns, together with Mario Casciaro. If you have read the book, I'd love to hear your comment, so please come and talk to me later. And feel definitely free to connect with me in all the major social channels, because definitely I'm going to be happy to keep chatting with you even after this event. Now, a little bit about Fortiorem. We are a small remote-first consulting company. Based in Ireland, but being remote first, we basically hire everywhere. And we are focused on AWS, so we are effectively a cloud consulting company. Most of our projects are cloud migration, training about cloud computing, building high-performance serverless applications, and even helping companies to reduce cloud cost. If all of this stuff sounds interesting to you, definitely let's have a chat, or if you are shy, you can just send an email to this address. And one of the things that I am particularly proud that we do at Fortiorem is that we invest a lot of our free time doing open source and creating content that is relevant to software engineering and cloud. And one of the things that we have been doing for almost 2 years now is this weekly podcast called AWS Bytes, where we share our opinions and ideas about AWS. So if this is something that interests you, definitely check it out and let me know if you like it. Okay, let's get into the talk finally. So what's the agenda for today? First of all, we're going to briefly try to describe what serverless is and why it is convenient. Then we are going to deep dive a little bit more on Lambda and try to understand how actually it works. And then we are going to write a very simple Lambda in JavaScript. And we are going to try to figure out what do we need to do after we have the first prototype to make it production ready. So serverless. This is one of the most contentious definitions ever. Everyone has tried to describe serverless, and honestly, there is no one definition that I like. So what did I do? Because I live abroad, I could ask ChatGPT, how do you describe serverless? What the hell is serverless? And actually gave me a long but interesting answer. So I'm not going to read through all of this, but just going to highlight the main points. So serverless is a cloud computing model where the cloud provider manages the infrastructure and automatically allocates computing resources to execute code in response to events or requests. So there is an automatic there is response and events, all keywords that are important. Then another bit here is that there are no servers to manage or provision, and the developers only pay for the actual usage of the application, not for the infrastructure. And another interesting point is that one of the most famous concepts or topics or technologies that gets associated with serverless is AWS Lambda, which is something we're going to be talking more today. So if I have to recap all of that, this is my version of it. Serverless is just a way of running applications in the cloud. Of course, there are servers somewhere, right? We just don't have to think about them. And you pay only for what you use. There are small units of compute, which are called functions, and those are generally triggered by events. So there is an event-driven model. Now, why serverless is interesting? There are certain benefits that I think are worth highlighting. First of all, when you do serverless, generally, and there is a big asterisk there, you have a lot more focus on the business logic. There are less concerns that you have to think about, so you can spend more energies thinking about what is it, the value that you are actually trying to provide. And that sometimes helps to increase the team agility. And not just that, but also the fact that you work with smaller units of compute, so it is easier to just divide those units between different people, to change some of them if at some point you have new requirements, or maybe if you want to experiment with new ideas. So that generally helps with agility. You get automatic scalability to some extent. We will see that there are constraints that you need to be aware, but generally the scalability story is much easier because you can go to 0 when you are not using the system, and it can scale significantly if you get a sudden increase of traffic. It's definitely not a universal solution. I'm not going to try to sell serverless as the best thing ever and the thing that everyone needs to go to, but definitely works well in many situations, so worth considering for most applications. Now, this is my opinion. I think we will be seeing more and more serverless in the future, so also another reason to have a look at it and try to figure out where it works and where it's worth using it. Talking a little bit more about AWS Lambda. Lambda is the function as a service offering that you get in AWS. Of course, it's not the only function as a service solution, it's the one that you get in AWS, and the one that I'm most familiar with, so I'm going to be biased and be talking only about this one. And I said that it is event-based, which, just to give you some examples, could mean that, for instance, if you want to build an API, you can have Lambda respond to an HTTP request. So there is an event, which is the request itself, and then a Lambda gets triggered to figure out how to respond to that particular request. It could be a new file in S3. Somebody drops a file there, you want to do some automation based on that file being there, that can be your event. It can be a job in a queue, so you can schedule different things to do, and then you can trigger Lambdas that will take care of performing that particular job. It can be orchestrated by step functions, or it can be run on a schedule, or you can even manually invoke Lambdas if you have to. Now, I want to try to do a simplistic thing where we try to figure out how Lambda actually works behind the scene. And we are going to be using the help of this little robot, which I didn't name, but let's pretend this is the Lambda engine. So this Lambda engine, what it does is responsible for actually making things run behind the scene. So it's going to look at events, and it's going to figure out, oh, there is a new event here. Is this an important event? Is there any Lambda that is associated to this event? And it turns out that in this particular case, there is a Lambda that needs to be executed. So we want to trigger this Lambda. But the problem is that this Lambda doesn't exist yet. Like, it's not there. We need an instance running somewhere, and there is no instance running. So the Lambda engine needs to make sure that a new instance is created on demand. So what it's going to do, it's going to figure out the code base needs to be somewhere for this Lambda. So it's going to take the code base from a bucket, an S3 bucket, and use that code to actually provision an instance of the Lambda in real time. When that instance is ready, it can pass the event to the instance, and that instance can start to run the code and run the business logic that is needed to handle that particular event. Now this Lambda is working in the background, and the Lambda engine can rest until there is a new event coming in. And this time it starts to think, okay, I have to run again a Lambda to respond to this event, but there is only one instance, and this instance right now is busy. So the only thing that the Lambda engine can do is to spin up a new instance for that Lambda. So again, it's going to take the code from the bucket, create a new instance, and pass the event over to it. So now we have two Lambda instances that are working really, really hard and processing two different events. At some point, the first Lambda finishes, so we can take the response and send it back to wherever that message needs to go. And after a while, the first Lambda is not doing anything. So the Lambda engine is actually figuring out, do I really need to keep this instance around? Maybe I can get rid of it and just free some resources. So it's actually gonna destroy that. Come on, destroy. Doesn't want to destroy. Okay. We got all the animations in one go. Okay, you got a preview of everything. So that Lambda was destroyed. The second Lambda finishes as well. And what happens now is that this one can be destroyed as well. And finally, we scale back to 0 because no more events are coming in. We don't need any instance running. Now, the summary of all of this is that events can trigger Lambda executions. The code of a Lambda is generally stored in S3, and it gets downloaded from S3 when you need to create a new instance. Instances are created and destroyed on demand only when new events come in, and if there aren't events for a while, instances will be removed. And the interesting bit, which is the one that I wanted to highlight here, is that one instance can handle one event at the time. So it's not kind of a magic multi-threaded mechanism where one instance can handle multiple requests. This is something to keep in mind for that scalability piece that we will be discussing in a bit. If we want to zoom in a little bit more in technical details, the engine that actually powers Lambda is called Firecracker, and it's an open source engine actually being used by other companies like Fly.io, for instance. And it's generally a tool that allows you to run micro VMs on Linux. So this is effectively what powers that instance. So when we think about one instance, there is an engine there that is actually running all of that. And the first time that you start a Lambda instance for a particular event, that event is a little bit unlucky because it gets that extra delay that is called the cold start. So this is the time that is needed to actually bootstrap that Lambda in order to respond to a particular event. Now, instances can be invoked synchronously, which is the case, for instance, for a HTTP or when you are invoking a Lambda manually. And that basically means you are waiting for a response straight away. Somebody is waiting in line for that response to be produced. Or events can also be asynchronous, so the invocation can be asynchronous, and that's the case, for instance, when you have an SQS queue or an SNS or an event bridge message. Now, the interesting bit is that a Lambda itself, like an instance, doesn't really know how it is invoked. The mental model that you can have is that it is just a function, and being a function, the only thing that it cares about is that there is some input, which is the event, and it needs to produce some output, which is the response. Now, what are some of the interesting limits of Lambda? First one, and probably the most famous one, is that you can run a Lambda for a particular event only for 15 minutes maximum. So if you need to take more than that to process something, maybe you have to do something that requires a lot of time to be computed, probably Lambda is not your solution right now, unless you can break the problem down and run it in smaller units where they might take less than 15 minutes. There is a limit in the size of the payload in terms of request and response, which is 256 kilobytes for asynchronous invocations and 6 megabytes for synchronous invocations. Now, this is changed recently just because there is a new mode that is called response streaming. So at least for responses, if you need to go beyond that limit, you can actually do that. Then there is another interesting limit, which is the limit of 1,000 concurrent executions. And if you think about what I just showed you before on how Lambda works, that kind of technically means that you cannot have more than 1,000 Lambdas running at a given time, which you might be thinking means that you cannot handle more than 1,000 requests at the same time. So let's say 1,000 requests per second if you have very fast requests. Now, this is not entirely true. First of all, because this is a soft quota. So if you actually reach that limit, you can reach out to AWS and say, I need more. And you can get a lot more if you have a good use case for it. And the other thing is that there is what is called like burst concurrency, which basically means that if you have a sudden spike of traffic, actually the engine is going to allow you to go a little bit over the limit for a while to be able to respond to that spike. And there is also a code size limit, and this is again just to encourage you not to build massive monolithic Lambdas and to limit the cold start as well. Now, there are more details there. If you want to check out all the limits, it is actually really interesting. There are some links there that you can check out if you want to understand a little bit more about them. Now, what about the pricing? Because we say that it kind of scales to zero and you only pay for what you actually use. So does this mean that Lambda is very, very cheap? Well, maybe. It really depends. I'm going to steal Teja's famous quote, it depends. But to try to understand the cost, you need to look at this formula, which it is actually very simple. And it basically says, for a Lambda instance, you have to allocate some amount of memory. And then this instance is going to be running for a certain amount of time. So you basically pay for that memory, which is going to have some kind of monetary value, multiply the amount of time you are actually running that particular instance. So just to see an example, let's say that if you allocate 512 megabytes, that's what you pay as a base unit. I don't know how many zeros there are, but it seems like a very small amount. But then if you're running that for 15 minutes, that comes up with this formula, and you basically end up paying $007, which is a very bad joke, so excuse me, I have another couple of them, so please don't leave the room. But yeah, the point is that we are paying for 15 minutes of compute less than 1 cent of a dollar. Now, that might seem very low, and probably is very low if you run Lambda sporadically, but if you have thousands of Lambdas running all the time, it might be significantly expensive, and it might get even more expensive than running just your own EC2 instance. So keep in mind that serverless is not a silver bullet for saving money. You always need to do your own accounting and your own pricing models and trying to figure out exactly when it is actually convenient for you. Chances are that you have very sporadic executions. It's the cheapest compute that you can have. But if you have more kind of consistent patterns, you might need to do your calculation very carefully. Now, I only spoke about memory so far. So you might be wondering, what about CPU? Like, do I get to configure CPU in a way or another? And the answer is kinda, because you don't explicitly configure CPU. CPU is automatically configured for you based on how much memory you allocate for your Lambda. And just to show you an example, in this table you can see that depending on which memory configuration you pick, you get a different number of virtual CPUs. So sometimes, even if you don't need a lot of memory, just because you need more CPU, it might be convenient to allocate more memory, which also makes your Lambda more expensive, but it might be faster. So we will see at the end how to find the sweet spot there. Okay, let's finally get to write some code. And we are going to write our first Lambda in Node.js. I said that a Lambda is just a function, so surprise, this is a Lambda. It's a function. And generally you call your Lambda function a handler, and it's async because you might want to use a wait inside this function and do different things. For instance, you can use fetch or call a database or use the SDK to connect to DynamoDB. And then the other two pieces are the event and the context. So event is actually an object. You can imagine just a blob of JSON that describes the event that is triggering that Lambda. If it is an HTTP request, that event is going to map out all the properties of an HTTP request. So the path, query string parameters, the body, and so on. If you have headers, all that kind of stuff. Then you also have the context, which is an object that can give you additional details on the execution context. For instance, what is the name of this Lambda? How much memory there is available? How long this Lambda has been running? And things like that you might want to use to do more advanced things. And then what do we do with this Lambda? Generally, this is the pattern. You get some data from an event, you run some business logic, you have to calculate something useful, and then you return a result. Okay, let's actually see a more practical example. Let's imagine we want to build an HTTP status checker. So we can pass a URL as an event. We want to call that URL and get the status code. So maybe something we can use, for instance, to crawl our own blog and see if we have 404s. We can use this Lambda to actually do all the calls and collect all the status codes. So the code is very simple. We just get the URL from the event. We expect that to be a property in the event. We use fetch to do a request. We console log that we are doing that request and that we got a certain status. And finally, we return that particular status. So, hooray, we have our first Lambda. But is this production ready? Well, we can deploy and put it in production, but should we be doing something more before actually going to production? And I think yes, but of course it's my opinion, so I'm going to be giving you some suggestions, but it's not going to be a comprehensive set of suggestions, of course. Now, the first suggestion is use infrastructure as code. And why infrastructure as code? Well, stop creating resources manually in your AWS accounts, like right now. If you're doing that, please stop. And I'm going to try to justify that. And the reason why you should be using infrastructure as code is because when you do that, all your infrastructure, everything you have in your AWS accounts is defined as code, which basically means you can keep it in your versioning control system, for instance, on Git. If you do changes, you can actually have an history of those changes. You can automatically create pipelines. For instance, when you merge a change to the master branch, you can trigger a pipeline that deploys a new version of the infrastructure directly. So you can create all these kind of automations. And that creates another benefits, which is basically you will have all your environments easily reproducible. So if you're using a development account to try something new, when you want to bring those changes to productions, you will have the confidence that actually you will end up with the same kind of setup that you used in development mode. But how do we do infrastructure as code? There are many, many tools, and I'm not gonna try to argue which one is best because each one of them has different pros and cons. If you really want to find out, there are a couple of episodes of that podcast where we fight and we argue over which one is best, but I'll let you check out the podcast. And just for the sake of showing you an example, I want to show today SAM, which is the one in the middle, and it's an AWS tool, and the name stands for Serverless Application Model. Now, the reason why I picked SAM in this particular talk is because SAM is a YAML-based infrastructure as code tool, which is specifically focused on making it a little bit easier to define infrastructure as code for serverless applications. It's a great tool when you want to go just beyond one Lambda. Maybe you have to provision an S3 bucket, maybe you want to use DynamoDB, maybe you want to create specific roles that connect everything together and give the right permissions. You can define all of these things in this YAML document, and then you can deploy from that YAML document rather than clicking in 100 different places in the AWS console. And I already gave you all these examples. So the additional point is that SAM is effectively an extension of CloudFormation. So if you have already used CloudFormation, it's pretty much the same syntax. It supports exactly the same syntax, but it just gives you some shortcuts to make that syntax a little bit more concise, specifically for things that are related to serverless. And actually, when you deploy, it is deploying using CloudFormation. So you can actually look at the deployment in the CloudFormation console and see exactly what's going on. Now, just to give you an example, this is what some code in SAM is going to look like. It's just a YAML. In this YAML, we are defining a Lambda function. We are defining an S3 bucket, and then we are defining an event where we are basically saying when a new file is created in this S3 bucket, trigger this Lambda. The second point that I have is observability. And when it comes to observability, we have to wonder, what does good observability look like? And in my opinion, that is good logs, good metrics, good tracing, which equals, ta-da, this is the other bad joke. Okay, this is the last one, I promise. Now I'm gonna be serious. Okay, I want to show you this library, which I really like. And by the way, there is Sarah there. So if you have complaints, talk to Sarah later. I don't take any complaint. But no, seriously, it's a really great library that you can use if you're doing Lambdas in Node.js. And it can help you a lot to do best practices when it comes to logging, creating custom metrics, and to do tracing. And I just want to show you very quickly what it looks like to use this library. So this is our Lambda that we just wrote. Let's say that we want to actually do structured logging. How do we do that? We can just import the logger from this library. We can create a new instance for the logger, and we can give it a service name, which is going to be used for every log line that we produce. So something we can use later when we want to query our logs. And then let's say that we want to print the event, because maybe that's something that can be useful later to see exactly which events triggered our Lambda. And notice how I am using logger.debug. So there is also a concept of log levels that we can configure. So I also want to log with the debug level the URL. And finally, we replace the console log with logger info to log out the status code that we got from that particular URL. Also notice how we are passing a string that identifies the log line, but also we can pass an object with additional information, and all of that information is going to be searchable for us. So this is how we specify the log level. For instance, here I'm setting this to debug, which is probably useful in development, but maybe in production I want to set my log level to info, because I'm going to be producing more logs. Therefore, I don't want to incur in too many costs if I don't need to print all these debug logs. And this is what we get in the end. So once our application is deployed and running, all our logs are actually JSON logs, so we get structured logs. And the advantage of that is that we can use a tool like CloudWatch Logs Insights to actually run queries on our logs. So that's something very useful when you're trying to troubleshoot a bug. And the idea is that our logs are not just text, but now it's data that is indexed and that we can use to actually do interactive searches. Okay, now let's look at metrics. We added logs. How do we add metrics? We can import these two objects from this library. Then we create another metrics object. This is kind of a client that allows us to create new metrics. And we can add some meta information, for instance, namespace and service name. And at this point, we can start to create new metrics. For instance, one thing that I want to do is that every time we just finish the request to a URL, I want to create a new metric that says successful request, but also has a special dimension that tells me what's the status of that request. So we can also query our metrics based on the status. And we can also create another metric. This is kind of a shortcut there when you don't need to use custom dimensions. And basically, this metric is creating something like successful request 5xx to map out all the 500 status codes, or it will have 2xx to map out all the 200 status codes. So again, it's a metric that we can use if we want to see all the different classes of status codes grouped together. And very important point, we need to remember to call this method because all the metrics are not sent straight away to the backend, but they are all accumulated into this client, so we need to remember to flush them manually. Now, why metrics are so useful? Because we can build custom dashboards, and we can use these dashboards to understand how our application is working in production. And I have a couple of examples here. For instance, this one allows us to see what's the distribution of the different status codes. Okay, I didn't want to show you an example about tracing, just because I don't think this example that we built has a lot of moving parts. Tracing is particularly useful when you have, for instance, a Lambda that needs to call to DynamoDB or maybe calls other Lambdas. So when you have a very advanced distributed system and you want to really understand what's happening in all the different parts. But if you enable tracing using Power Tools, you will be able to see visualizations like this with X-ray. Now, observability is very cool, but it is also very hard. Fair enough, it takes a lot of time to do it right, and you need to invest a lot of time to understand the principles, the best practices, and then actually to update your code to use those best practices. So you might be wondering, okay, do I have to do all this hard work for every single application, or can I get something for free? And actually, at Fortheorem, we thought a lot about this problem because we spend a lot of time with our customers just helping them to set up best practices for observability. And eventually, we come up with this idea that there is some automation that you can put in place that will apply some of these best practices out of the box for you. And so we built this tool that is called SlickWatch that basically allows you to get automatic alarms and dashboard for CloudWatch just by looking at your infrastructure as code. So the way it works is that if you do infrastructure as code, you generally take that and deploy it to AWS. With SlickWatch, you have a step in between which is capable of looking at your infrastructure as code, understand what's inside your infrastructure as code. So for instance, it's going to be able to see, okay, you are using a Lambda, you are using an SQSQ, you are using an SNS topic. What are some of the best observability practices that I will need to apply just because I'm using a Lambda? And then based on that, it's going to create a new version of your infrastructure as code where it's automatically adding CloudWatch dashboards and alarms. And then at that point, if you deploy, you get your stack ++, like enhanced with all these best practices for you. Now, I said that it works with different tools. It works with SAM, it works with CDK, it works with serverless framework, but just want to show you how to deploy it with SAM. There is a macro that you need to install, so you just follow the link and install it to your own account. And then basically, you just need to add this line to your template, and then you deploy that, and off you go. Of course, you can customize the configuration, but that's pretty much all you need. And the benefits of that is that this is what you have before SlickWatch. Basically, you go to your alarms dashboard, and there is nothing. And this is what you get just by enabling SlickWatch in your project. 0 configuration needed. and you will get a bunch of dashboards. You will get also one single dashboard that contains all the relevant things for your own specific application. So a single pane of glass where you can go and check if something is going wrong, or just to understand what is the health condition of the application. And you can also configure an SNS topic to receive the alarms. So that's something that you can easily integrate, for instance, with your own Slack to get the notifications somewhere else when something bad happens. Now, another topic that I want to show you is how to avoid code duplication. Very commonly, when you build a Lambda, a more real-world Lambda, this is what you need to do. You have a lot of boilerplate at the beginning because maybe you are trying to decrypt some environment variables using KMS. Maybe you are deserializing the input that comes, maybe, I don't know, it's a form and you need to decode all the different fields. Then you need to validate this input. You need to do authentication, authorization. At some point you are happy enough. This event is good, we can process it, and this is our actual business logic. And we get a response, but probably we need to do more stuff with that response. We need to validate that it's shaped correctly. We need to serialize it to send it back to, I don't know, an HTTP response. And also there might be errors, so maybe we want to create an error handler just to make sure that if something goes wrong, we do logging, we do monitoring, and all these things correctly. So long story short, there is a lot of boilerplate there. And the promise of Lambda was we want to focus more on the business logic. So why do I have to worry about all this boilerplate all the time? So what can we do to actually try to separate all this boilerplate from the actual business logic? And there is a library called MIDI that you can use to try to do that. It's going to help you to make your code a little bit cleaner in the context of Lambda. So if you like this project or if you already use it, please give it a star. And the idea of MIDI is basically it takes the boilerplate away. And let's see how. The first thing that allows you to do is basically to move all that important part, the business logic, into its own handler. And the idea there is that you should assume that this is kind of the happy path. All the boilerplate and all the problems are taken away, so you can focus there only in handling the actual business logic that is important to you. Then the next thing you can do, you can midify that handler, which basically means you can call this MIDI function and pass the handler inside, which is going to basically create a middleware engine for you and wrap your Lambda, giving you the ability to run code before and after your actual business logic. Very similar to what Express does if you use Express in Node.js. So at this point you can call .use and basically attach different things that are important to you. For instance, KMS, input deserializer, validation, authentication, and so on. So basically now from line 3 to 6, we have what's important to us, and everything else has been moved out into middleware functions. Now, just to see a more realistic example, since PowerTools also supports MIDI, let's see how we can combine PowerTools and MIDI to make our code a little bit better and a little bit cleaner. So this is the idea. Right now we are doing logging and metrics, and there is a little bit of code duplication, a little bit of boilerplate there. So we are going to be trying to use MIDI to get rid of that boilerplate. So the first thing we need to do is to import MIDI. Then we import this inject Lambda context. And finally, we are not going to export our handler straight away because we want to export the midified version of our handler. So we have to call MIDI on our Lambda handler. And at this point, what we can do is to use inject Lambda context logger, which basically creates a middleware that exposes our logger across the lifecycle of our request. And the advantage of that is that now we can get rid of this line, which is a bit of boilerplate. Why do we have to explicitly say that we want to log the event? This is something that a middleware can do for us. And it's going to happen for us if we just configure this environment variable in PowerTools saying, I want to log the event every time there is a new request. So we got rid of that small piece of boilerplate. Let's see if we can do something similar for metrics. It looks very similar. We need to make our middleware engine aware of our metrics client. So we need to import middleware there, and then we can use this particular middleware. Now, the one thing that we can remove is this line there, because again, why do we need to remember every single time that we need to flash the metrics? And imagine that you have an error somewhere that you are not capturing. You might not get to that line, so it's better off we are better off using a middleware engine that can also work in case of error and make sure that that function gets invoked every time so we can see our metrics. So because we are using that middleware engine, of course, this is done for us out of the box. So we also removed that little piece of boilerplate. Now, these are not the most amazing example ever, because of course, there are a lot of other use cases, but I just wanted to show you Power Tools in combination with MIDI. MIDI also comes with a lot of middlewares out of the box, built in the standard library of MIDI. For instance, to do request and response validation, to do SSM parameters, secret manager, app config, error logger, and so on. There are, I think, something like 30 middlewares. So lots of use cases are covered for you out of the box. And it's very easy to build your own middlewares if you have to. Now, because I'm running out of time, I'm just gonna skip all of this. I hope that the benefit of MIDI is clear, and just invite you to support the project. As of today, I think MIDI has more than 10 million downloads per month, I believe. So it's a significant amount of users. And most of the work is being done by Will Farrell, who is maintaining the project. So definitely consider, if you use MIDI in your company, definitely consider sponsoring Will, or at least contribute to MIDI with even just sending comments, sending issues, or even better, if you can take the time to send a PR where you see that there is some feature missing. One last piece of advice that I have is about performance. Remember that I mentioned that you might be better off having more CPU, which means more memory, because it might be faster. So how do we know, like, what is the sweet spot between memory and CPU? And if going faster with more memory is actually going to be cheaper than maybe going slower with less memory. And it's actually not easy to figure out an answer to that. So the best solution that I found is this tool called Lambda Power Tuning, which is a project by Alex Casalboni. And this project effectively is a step function that simulates your Lambda against a bunch of different configurations in terms of memory. And at the end, it gives you a graph. And in this graph, you can actually see with all the different memory configurations, if it gets faster, if it gets more expensive, and you can figure out what is the sweet spot for you. So sometimes you can just go slower because, I don't know, maybe it's cheaper. Sometimes you might want to be even a little bit more expensive if it gives you faster responses. Sometimes there is something in between that is a good trade-off for you. And just to finish off, I have some other high-level suggestions. If you're using JavaScript to write Lambdas and you have to interact with AWS, try to use the new AWS SDK because it's much more modular. It's better for testing. It comes with a lot of mocking built in. You can also use a module bundler, and together with the SDK v3, you will get a lot of benefits in terms of code bundle size. If you use SAM, actually SAM has ESBuild built in, and you can just configure that and it's going to work out of the box for you. If you use TypeScript, you can also use it with SAM, and there are libraries for typed events, so you can get the benefits of type checking on your events and your responses. And other tricks like the one we saw with the metrics client is that if you have global objects, make sure they are initialized outside your handler, so they get initialized only at the call start, and then they are available for the next invocations. And finally, if you have to do configuration, it's a good idea to do it through environment variables. Okay, that's basically all I have. I think the summary is a little bit redundant, so I'm just gonna keep the last few minutes if anybody has questions.
Thank you so much. That was great. Are there any questions? We have time for one question, I think. All the way there. Yes.
Ciao, Luciano. I would like to ask you, based on your experience, which are the, let's say, most common use cases for Lambdas?
That's a good question. I have seen many crazy use cases. I think the most common in general is for APIs, just because it's very easy to build an API. It's very easy to bootstrap a new API. You don't have to think too much. How are we going to host this API somewhere? Do we need a cluster? Do we need something like that? For simple APIs, I think Lambda is probably the most common and simple use case. Other use cases that I've seen and that I really like is when you need to do like background processing. You can just ship stuff to a queue, and then you can have Lambdas that are gonna spin up on demand only when you have jobs available, and if you get a spike of jobs, it will spin up more Lambdas. So it's very easy to have a system that auto-scales to handle the number of tasks that you have in the queue. So these are probably the two most common that I've seen. But yeah, I've also seen Lambda being used, for instance, to run inference models for, I don't know, insurances to try to predict what's going to be the outcome of a specific deal. So really, you can use Lambdas for almost every use case you can think of.
Thank you so much.
Thank you.